Hi everyone. In this video, you will learn how to estimate limits using tables. Let's start with an exercise. Determine whether the following sequences approach 10 from the left or from the right. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. I start by drawing the x-axis. Then I add 10 to my x-axis. And I ask myself, are the terms in the first sequence smaller or bigger than 10? And I believe all of the terms in the first sequence are less than 10, so they approach 10 from the left. When it comes to the second sequence, all the terms in the second sequence are bigger than 10, so they approach 10 from the right. This idea of approaching a number from the left or from the right will be very useful to us when it comes to estimating limits using tables. Let's take a look at the next problem. We must estimate the limits of the following functions as x approaches 2. Remember, a limit is a value to which the outputs of the function get closer and closer to as the inputs approach 2. The inputs can approach 2 in two different ways. They can approach it from the left or from the right. In the first table, as the inputs approach 2 from the left, the outputs approach the value of 0.3. As the inputs approach 2 from the right, the outputs approach the value of 0.3. So, no matter how you approach the input of 2, the outputs get closer and closer to 0.3. In that case, we say that the limit of this function as x approaches 2 is 0.3. We write it down in the following way. We say the limit of this function as x approaches 2. X arrow 2 under the words limit mean x approaches 2. And we determine that this equals 0.3. Let's try to apply this reasoning to the second table. As the inputs approach 2 from the left, the outputs approach 8. As the inputs approach 2 from the right, the outputs approach 11. In this case, there is no one value to which the outputs get closer and closer to as the inputs approach 2. In that case, we say that the limit of this function as x approaches 2 does not exist. An easy way to remember it is each function can have only one limit at a particular point. So if from the left you're approaching a different value than from the right, then we say that the limit does not exist. I have another problem for you. If you would like to try this problem on your own first, this will be a good time to stop the video. Now, as the inputs get closer to 0 from the left, the outputs get closer to 10. As the inputs get closer to 0 from the right, the outputs get closer and closer to 9. Because these two values are not the same, we say that the limit does not exist. In the second table, as the inputs get closer to 2 from the left, the outputs get closer to 3. As the inputs get closer to 2 from the right, the outputs get closer and closer to 3. This means no matter how we approach 2, the values of the function get closer and closer to 3. We then say that the limit of this function is 3. I included this example because this function is not defined at x equal to 2. Note, you cannot plug in 2 to this equation, to this formula, because then you would be dividing by 0. Even though this function is not defined at 2, the limit of this function at 2 exists and equals 3. Sometimes tables can look slightly differently. Let me give you another example in which the tables are slightly different than the ones you saw so far. We must estimate the given limits using the provided tables of values. If you would like to try this exercise on your own first, you can stop the video now. Let's take a look at the first limit. I am given now two tables. The first table gives me the limit from the left. The second table gives me the limit from the right. As the inputs get closer to 0 from the left, the outputs get closer to 1. As the inputs get closer to 0, the outputs get closer to 1. So, no matter if I'm approaching 0 from the left or from the right, the outputs get closer and closer to 1, which means that the limit of this function as x approaches 0 is 1. In the second example, first, the table is horizontal. Second, it's half empty. We must complete it first. Let's plug in some of those numbers to the function absolute value of t divided by t. Let's start with 1. When I plug in 1 to this equation, to this formula, I get 1 absolute value divided by 1. Absolute value of 1 is just 1, so that is 1 divided by 1, which is 1. So, plugging in 1 to this formula gives you 1. Let's see what happens when I plug in 0.5. 0.5 absolute value divided by 0.5 gives you 0.5 divided by 0.5. Absolute value of 0.5 is just 0.5. Now, dividing the same number by itself gives you 1. So the second entry is also 1. The same thing will happen when I plug in 0.1 and 0.01. Things will change when I plug in negative numbers. Let's try to plug in -1 and see what we get. Absolute value of -1 divided by -1 is, absolute value of -1 is 1, so I get 1 divided by -1. That's -1. So plugging in -1 to my function gives me -1. What about -0.5? -0.5 absolute value divided by 0.5 gives me, in the numerator, 0.5. In the denominator, I was dividing by minus or -0.5. So in the denominator, I have -0.5. That gives me -1 again. So I get -1. Same thing when I plug in the next two inputs. So as inputs get closer and closer to 0 from the left, the outputs are always -1. As inputs get closer and closer to 0 from the right, the outputs are always 1. From the left, I get -1. From the right, I get 1. In that case, we say the limit does not exist. I wanted to include this example because neither of these two functions is defined at the input of 0. You cannot plug in 0 to this expression because then you would be dividing by 0. You cannot plug in 0 to this expression because then you would be dividing by 0. Even though these two expressions are not defined at 0, the first one has a limit at 0, and that limit is 1. The second one doesn't have a limit at t equal to 0. I have one more exercise for us. If you would like to try this problem on your own, this will be again a good time to stop the video. Your friend went for a 10-second jog. Now I give you two tables that show your friend's average speed during various time intervals. And I want you to estimate your friend's instantaneous speed at 5 seconds. Let's take a look at the first table. I look at the first column and I see that these intervals get shorter and shorter. As these intervals get shorter and shorter and they're closer and closer to an instantaneous moment at the 5th second, the outputs of this function get closer and closer to a number 7.5. In the second column, or in the second table, I also have intervals. This time, the time intervals are after the 5th second. Yet, the intervals get shorter and shorter as well. As they get shorter and shorter, and they get closer and closer to the instantaneous moment of the 5th second, the speed appears to get closer and closer also to 7.5, which makes me think that at the 5 seconds, your friend's instantaneous speed was 7.5 miles per hour.